Hello, my name is METİN ARIDAŞIR. This is 18th part of explanation of my theory. In this video, I will emphasize that according to my theory and my formulas, how can we find or determine the electron motion forms velocity which are accelerated by applied voltage, etc. This is X-ray continuous spectrum graph. Under the some size applied electron volt on electrons, say 30 keV. It's not important now. According to my theory, I say that L lambda n, and I say that lambda n minus delta lambda, if you remember. According to my theory and my formulas, this X-ray graphs, these kinds of X-ray graphs, continuous spectrum graphs, represents what? Represent, for instance, this graph represent what? Before that, Ln make it be 0.2 nanometer. Okay. Again, according to my lambda n delta minus lambda n minus delta lambda equal to 1227 divided by voltage, 30 keV, say, divided by, will be equal to 0.0409 nanometer. Okay. We know these two quantities. Okay. What represents this graph? Now, always X-rays continuous wave graphs always represent free electron motion form, but relocating free electron motion form at a certain velocity, or sometimes maybe accelerating velocity or decelerating. It's not important. According to my formulas and my theory, we can solve that problems, accelerating problems. But for photographic picture, say for instance 30 kV, 40 kV. Okay. Now we have this graph. What represents this? What represents this graph? Relocating electron motion for here, left side and direction in the direction of 0 degree. Here 90 degree, here 0 degree. Here this point Ln 0.2 nanometer represents 90 degree. Then here represents lambda n. Lambda n equal to 0.2 nanometer. Here and here here lambda n minus delta lambda equal to 0.0409 nanometer. Here 0 degree. Relocation direction. Okay? But 360 degree, we can solve this problem, but I don't want to confuse your mind now. Okay? Here, we interested in what is electron velocity? In the direction, of course, 0 degree. But before this, shortly, here, wavelength, continuum. This is continuous, like this. Not discrete, not spacing. Continuum, okay, continuum wavelengths. We cannot separate wavelengths. Continuous, okay. There is no quantum. In this graphs, in this situation, there is no quanta. Quantum states, no quantum states, continuous. We pictured with discrete wavelengths, but we do that. Now, this is 90 degree. Here say alpha 1. Here say alpha 2. Okay, at this point, lambda alpha 1 equal to lambda n minus delta lambda cosine alpha 1. At this point, lambda alpha 2 equal to lambda n minus delta lambda cosine lambda 2, etc. And at this point, wave velocity, different. We say d equal to c minus, according to my theory and my formulas, d equal to c minus ve cosine alpha 2. Different wave velocity. In that point, okay, in that point, the wave velocity is c minus electron velocity cosine alpha 1. Okay, we can infinitely, we can, at any point, we can find wave velocity and wavelength, variable wave velocities and variable wavelength of waves of any point in the continuous graph. Okay, at any point we can find these sizes. And there is no quanta. There is integral. Okay? No. Here. In this video, I will emphasize how can we find or determine the electron motion forms velocity, which is accelerated by applied voltage. We focus on that now. In this graph, lambda n minus delta lambda equal to 0.0409 nanometer at this applied voltage, and lambda n equal to 0.2 nanometer. Okay? Okay. What's our concepts? D is equal to C minus V, electron velocity, cosine alpha. Okay. In this direction, 0 degree equal to, then we will calculate that. This is one of our concepts, D. It is important. Then lambda alpha equal to lambda n minus delta lambda cosine alpha. Here 0 degree. Lambda n minus delta lambda cosine 0 degree. Lambda alpha. Okay. Lambda alpha is what at this point? Cosine alpha, what? Firstly, we will find delta lambda. How can we find this delta lambda? It's so basic. Here we see on that graph lambda n minus lambda n minus delta lambda lambda n minus lambda n cancel, minus and minus, plus delta lambda. Okay, what is lambda n? Lambda n 0.2 nanometer minus, what is lambda n minus delta lambda is equal to 0. Okay, again, don't confuse. Lambda n minus lambda n minus delta lambda equal what? Here, we want to find that delta lambda is important for us, okay? Here, lambda n, we know 0.2 nanometer minus lambda n minus delta lambda is equal to 0.0 nanometer equal to. Cancel, and these two of that plus 0.2 minus 0.409 equal to, again, 0.2 minus 0.0409 equal to plus 0.1591 nanometer. Delta lambda is equal to 1591 nanometer. We understand that? Okay, we understand, I guess. We found delta lambda easily. Delta lambda is equal to 0.1591 nanometer. Okay. Yes. According to my theory, while relocating electron motion form, its frequency doesn't change. Its frequency constant frequency. And variable wavelength. Variable. In continuum. Variable. Wavelength, constant frequency. According to this principle which I put forth, frequency is equal to C divided by lambda. This is for at rest, but going on, produce and propagate successive waves, electron motion forms. At rest, not relocating, but in all directions, same wavelength, propagating wavelengths, electrons. Equal to, not change. This is C minus cosine alpha divided by lambda n minus delta lambda cosine alpha. Like this. Changing wave velocities. Here, D. Wave velocity change. Okay. And changing wavelength, but same constant frequency. Okay. This is so important. At this 0 point, cosine 0 equal 1. Okay. Because of this, lambda n minus delta lambda is equal to 0.0409. Okay. Then, D equal to C minus V cosine 0 degree. It's important. This is 1. D equal to C minus V because of this is 1. Okay. Don't forget this. And remember my relationship, formulas relationships. Frequency equal to C divided by lambda equal to C minus VE because of 0 degree divided by lambda n minus delta lambda because of this 0, 1 lambda n minus delta lambda. Okay, equal. These are equal. Same. And according to my theory and formulas, really shortening or enlarging waves, successive waves, and really shortening wavelengths, enlarging wavelengths there are. Okay. delta lambda divided by lambda n will be equal to, divide really, it's really valid. Don't confuse with Doppler shift. They say, accepted physics theories say, appearance wavelength, appearance frequency, appearance wavelength, appearance shift. Okay, in expanding universe or anywhere, but in everywhere, in every scale, really shortening and enlarging there, and this formula related. This is my main relationship and my main formulas. Okay, see here. We know delta lambda, we know lambda n, we know c, and we will find electron velocity. Okay? We find delta lambda according to, in the context of my theory and my formulas, from that data. Now, here we are. Delta lambda is equal to 0.1591 divided by 0.2 equal to divided by c. What is v? Electron velocity in this condition. Immediately we can do that. Quickly we can do that. 0.1591 divided by 0.2 equal to 0.7955 multiplied by, yes, 238,6,500 kilometer per second. This is electron motion forms velocity in the direction of 0 degree under the 30 keV applied electric potential effect. Again, I check 0.1591 divided by 0.2 multiplied by, yes, 238,650 kilometer per second. We find that. And corresponding, this is important now, corresponding wavelength. Okay. We find electron velocity equal to 238,650 kilometers per second. Okay. And its corresponding wavelength in the direction of wavelength of its successive waves at 0 degree direction. It's important. Okay. This is corresponding wavelength. Lambda n minus delta lambda. Corresponding wavelength. Okay. at this point. But at this point, corresponding wavelength different. At this point, different. But at this direction, for this velocity, electron motion form, wavelength is lambda n minus delta lambda is equal to corresponding wavelength lambda n minus delta lambda. Here, minus delta lambda corresponding wavelength is equal to 0. We know before 0.0409 nanometer. Okay. Shortly, I told you how can we find the electron motion forms velocity under these conditions. Yes. On the next videos, after showing that, I will make comparison, my results and accepted physics results. Okay. Quickly, what will I do on the next videos here? Okay, 30 keV, 100 keV, 1 megavolt under this connection. Lambda n minus delta lambda x, lambda n minus, for different electron motion forms, different size of electron motion forms. Okay, I will do that. And what are my variables? What will be my variables? In accepted physics theories, 1. There is no distinction of different radius wavelength electrons. Okay. I will do this, say, for 0.2 lambda n. Lambda n equal to 0.2. Or lambda n equal to 0.5 nanometer. Okay. Lambda n minus delta lambda will not change for any different wavelength, different size electrons. But velocities will be changed. There is no distinction of different radius wavelength electron sizes, electron kinds in accepted physics theories. 2. In accepted physics has only two variables. One of electron velocity under the effect of a certain applied voltage, applied electric potential. Electron velocity. Say voltage x keV, for instance, velocity x velocity, and wavelength x wavelength. Say what wavelength? Electron wavelength. One kind electron. There is one kind electron in accepted physics. Okay. Not change. Doesn't change. In accepted physics has only two variables, one of electron velocity, one of wave. There is no wave velocity distinctions. Remember, I have different wave velocity concept. Okay? At this point, wave velocity different. At this point, wave velocity different. At this point, wave velocity different. Okay. And yes. Okay. Shortly like that. Shortly like this. Have a good afternoon. See you later.